is just a way to organize data. If you want a career in computers, something to do with computers, that's what everything is organized in. Matrices. Matrices is the plural. Matrix is the single. You can see the plural version of it right here, singular version. First, we need to recognize like what kind of matrix we have. We call them by their rows and columns. These are the columns up and down. Correct? Those are columns. Would you believe that there are 4 columns to this? And there are 3 rows which go this way. Cool? We call this a 3 by 4 matrix. You do rows, then columns. A 3 by 4 matrix is what that says right there. Okay? 3 rows by 4 columns. Awesome? Each dude in there is called an element. So like this particular element right here, since this matrix's name is capital A, they use a lowercase a to say that you belong to capital A matrix right there. And it's in position 3, 2, meaning row 3, column 2. You see how this is in row 3, column 2. How they did it like that? It's 3, 2. Are we okay with all that? Next, here's what they can do with that. They can organize information. So here's a bunch of stuff about West High School football team and their 5 running backs throughout the season. The coach wanted to compare their stats, so they made up a matrix for them. You got Joey doing all this, Deshaun doing all this, and etc. It says organize the data in a matrix from greatest to least attempts for attempts. So do you see how they made these different little categories? You got a player, number of games, attempts, yards, average, and TDs. That's all the information that the coach had for stats. They made these columns out of those and these rows, and you see how they organized the attempts from greatest to least also right there. Cool? What are the dimensions of this matrix? You and Pal get that done. Is it a 3 by 4? Is it a 5 by 2? What are the dimensions of this matrix? Dimensions are rows by columns. How many rows are there? 1, 2, 3, 4, 5. Columns, how many columns are there? So this is a 5 by 5 matrix. Is that all right? Rows by columns. Is everyone good? What value is A34? Right? Sometimes you'll see a comma between the 3 and the 4. Sometimes you won't. It just depends. So what's the 3? Is it a row or is it a column? Always row first. 1, 2, 3. Here's row 3. And then column 4. 1, 2, 3, 4. Isn't that this guy right here? So we'll say A34 equals 7.6. 7.16. Excellent. Next guy. Bata. You're shopping for a new smartphone. You discover there are many options available. Organize this data into a matrix. Okay? So let's do this. We'll save a little time, and I will help you. We've got how many options? 4 options. And what do we got about them? We've got price, we've got memory, we've got color, and we've got interface. Correct? Well, let's make the matrix look like this. You can organize it different ways if you wanted to, but wouldn't the 4 different things kind of be like our rows? We've got option 1, option 2, option 3. Wouldn't those be like our rows? And all these different things inside of there be our columns. So make something that looks like that, baby. You can pause the video to draw that. Let's get that sketched a little bit here. Then once you've got this made, I'll help you with option 1. Right? Option 1, there's all that information. According to option 1, the price was $420, so I'll put that right there. The memory was 512. The color was 24. And the interface was infrared. So we'll just do that, and I'll and Pal work on the other for this matrix. So you can pause the video and get that finished also. So nice and neat and organized. Price, memory, color, interface. Cool. Next page. Operations with matrices. We can add them together. We can multiply them together. We will never multiply matrices. That's a little harder than you think. It's not that hard, but it's something that calculators can do that for you. So why explain it to students? Because once you figure out how to do it in the calculator, you just do it in the calculator. But we can definitely add and subtract matrices. Here's the trick, though. The matrices must have the same dimensions. If the first matrix is a 2 by 3 matrix, the only thing you can add to it is another 2 by 3 matrix. You can't add 3s and 4 by 5s together or anything like that. They must have the same dimensions. So, part A right here. Do these have the same dimensions? It's just what you think. you'd add this, well, whatever the operation is. If it's add or subtract, you'd have to do that operation. In this case, it's adding. Let's take this dude and this dude, the ones in corresponding positions, and add them together. We'll get another 2 by 2 matrix out of it, so I'll start with a nice little cool matrix. 6 plus 4, how much? 10. Then I don't care which way you go. There's no specific order, but just all the dudes in corresponding positions. You need a negative 7 plus 2. Isn't that a negative 5? Correct? This is 2 plus a negative 5. And then you got a negative 12 and a negative 6, which is how much? Negative 18. Then you close your matrix up. You can add matrices very, 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 very simply. Adding is real simple. Next guy, what are we doing? Adding or subtracting these matrices? It's harder than you think. You got to really be careful. Do we have the right dimensions to even do this? What's the first matrix dimension-wise? Is it 2 by 3 or 3 by 2? What is that guy? So 3 by 2. It's rows first, then columns. I get it backwards every once in a while too. 3 by 2 matrix. Is this also a 3 by 2 matrix? And we need to subtract them from each other. So I'll start with my matrix right here. Negative 2 minus 4. What do you get? Negative 6. And then I go over to the right. I just kind of go up here with this 8 minus a minus 3, which is a what? 11. Finish this matrix. Subtract those from each other. That's the wrong button. 3 minus 2 is a 5. Negative 4 minus 1 is a negative 5. 10 minus 6 is 16. And 7 minus 8 is negative 1. Goody? Big time ACT/state assessment question. Add these together if it's even possible. Also, seen this on the STAR test many times, which you're all past the STAR test, but taking a scalar, it's just some sort of number, times a matrix. It's just very similar to the distributive property. You just take this number times everything in the matrix. You can take any scalar you want to. This is a negative 12 though, is that right? Yes? Yep. And this is a 4 right here. Okay? So we just take negative 4 times all of those dudes. It's just a scalar multiple, so negative 4 times 12 is a positive 48. And then just finish that up. Just take negative 4 times all those terms. Started with a 2 by 4 matrix. You will end with a 2 by 4 matrix. No. What I'd like to do is skip these first 4, which is very similar to what we do on the next page. Let's just go to these. But now we've got 4 different matrices given to us. Matrix A, B, C, and D. They're saying, let's do this. We need 4 times matrix B minus 2 times matrix A. Let's substitute in, first of all. We've got a 4, which is like a scalar multiple, times matrix B, so I will put that. It's matrix B, which is 8, negative 1, negative 2, 7, minus 2 times matrix A, and then we've got to see if this is even possible to do. I substituted in. Now I see if it's possible. Multiplying the scalars through will not change the size of the matrix. Are we cool with that? Is this matrix, which is a 2 by 2, the same as that matrix, which is a 2 by 2? Can we add/subtract them together? So that means I can move forward from here. Follow the order of operations. Don't we do all the multiplying before we do the subtracting? So let's multiply 4 through in my green matrix right here. And then slow down. Don't get ahead of me. Got my green matrix. Multiplied a scalar of 4 through there. And I feel that subtracting is the most difficult thing to do. I like to add matrices together instead of subtract them. So instead of just multiplying a 2 times this red matrix, what do you say we multiply a negative 2 times this matrix, which since we distribute the negative through, that would turn that into a plus when we're all said and done. You with me on that? Take negative 2 times all of those. So this would become a negative 12, a positive 8, and etc. I am using the negative in my scalar multiplication portion of it, so that means that now you are adding the matrices together instead of subtracting them from each other. So now add them together. Got to be the same size, and these are the same size. But adding them is so much easier than subtracting them, in my opinion. And check yours with mine. Next guy, substitute in. You got a negative 8 times matrix C plus a shui times matrix A once you've subbed in, decide if it's possible. The scalars mean nothing. It's all about the size of the matrices. Do they have the same dimensions to where we could add/subtract them together? Yeah. So use the scalar. This is a 2 by 2. That's a 2 by 2. It doesn't have to both be the same numbers. You can do a 2 by 3 and a 2 by 3. They have the same dimensions. It doesn't have to be what you call a quote-unquote square matrix where it's 2 by 2, same dimensions. So 32 and 48 and 96 negative 56. You can use a calculator. I got no problems. I have a calculator stored in my skull. And once you get them, add them together. Negative 87, right? Is that right? 56 minus 15, get 1. Pretty simple. And you can do all this in your calculator. It's simpler to do by hand. It takes longer to type it in your calculator. One more. Negative 5 times matrix B, which is 8, negative 1, negative 2, 7, minus the deuce times matrix D, 9, 6, 0, negative 2, 8, 0. We would like to add/subtract these from each other. First thing you got to check is if it's even possible to do. Is this possible? Blue one is a 2 by 2. Green 3. You cannot do it, so there's no sense in even going through the scalar multiplications because it'll still be a 2 by 2 and a 2 by 3. So you're right, not possible. Okie doke. Now let's get to the good stuff. Using your graphing calculator to solve a matrix. They've got a system right here, which I'll write a little bit bigger. 3x minus y equals 14, and 2x plus 4y equals 0. Top guy, linear or nonlinear? Top guy, linear. All variables, no product of variables, no variables in the denominator. Bottom guy, linear or nonlinear? If we're solving linear systems, the graphing calculator can do the whole thing for you by way of matrices. What we need first is to write something called an augmented matrix. Okay? So where I have this written is where I want you to write your augmented matrix. What that is you take away times, you're just left with a coefficient matrix and a constant matrix put together. So here's what it would look like. Start with a matrix like this. And let's check this dude out here. We're listing only the coefficients. What's the coefficient of x? What's the coefficient of y? Negative 1. Then, isn't this where the equal sign is located right here? So we'll do this. We'll put a little bar right there. Sometimes you'll see that as a dash. Sometimes you see it as a solid bar. It means no difference. And then isn't that constant right there a 14? Close your matrix. There's one row right there. What's my bottom row going to be? 2, 4, 0. This is called an augmented matrix. The dude on the left are all the coefficients. The dude on the right are all the constants. And when you put those together, it's called augmented. What we can do is take this and punch it into our calculator and use a little function called reduced row echelon form, which would be an interesting thing for you to Google of how to do that by hand, which all us math teachers had to do even when we had calculators. It takes a long, long time to put a matrix in reduced row echelon form, but there's no need for us to teach you how to do that anymore since the calculators do it. So let's learn how to, number one, enter stuff into a matrix in our calculator. Over here, do you see where your math button is? Below it, there's a button that says x to the minus 1 right there. What is the second function of that guy? So let's hit second matrix. Your says in it depends on if your calculator's new or it was somebody else's. But in here, we need to scroll over to the edit guy right there. And you have a bunch of options for all the different matrices. You can have like 7, I don't know, maybe 10 different matrices at one time. Right now, to see how I have matrix A right here. Let's go to matrix A and just hit enter. And we edit it from what we want it to be. Mine's already set up as a 2 by 3 matrix. I don't know if you had anything or nothing at all, right? Do you see how my cursor is blinking right here? You can change those to whatever you want it to be. So we want this. What kind of matrix is our augmented matrix that we're trying to punch in right here? 2 by 3. So I need this to say 2 by 3, which it does. If yours doesn't, make it say 2 by 3, and I will help you if you need help with that. 2 by 3, bring your cursor down to right here, and you see how right here in the corner it says like 1, 1, because that's where we're located. All we got to do is punch these numbers in right here that are in our augmented matrix and watch how the order it goes in. It will work across. So don't we want the first one to be a 3? You with me on that? Hit enter. It'll change that dude to a 3. Then the cursor jumped over here. What do we want that guy to be? -1. Hit enter. Then a 14 and hit enter. Then 2, enter, 4, enter, 0, enter. And there's our augmented matrix typed into this calculator. Sound cool? Now this is the weird process. It takes a bunch of times to do this to remember what to do next. Here's what we want to do. Let's quit out of this. Second, quit. Just quit out. We've typed that matrix in. It's stored in position A. Now let's go back to second matrix. And what we want to do now is do some math on it. Right? We have it stored in there what we want. We want to do some math on it. So I'm hovering over the math portion. We're all good. Then we've got all these different choices, right? You can go down or you can go up. The easier way to get to what we want is to go up to choice B. You might make a note, well, it's written right here on your worksheet, that we want to use reduced row echelon form. That's what RREF stands for, reduced row echelon form. Math B is where it's located. It's so many options. You went 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C, D. This is option B. Looking through all those options, they had numbers in front of them, numbers in front of them. We want option B. Cool? Maybe? Hit enter. It will take us back to our home screen, but it's sitting there waiting for us to say, what would you like to do reduced row echelon form on? Don't we want to do it on matrix A, which is stored in our calculator? So we got to go back to second matrix again. And now do you see where my cursor is? Waiting on matrix A, waiting on matrix A. Just hit enter. And it will say, aha, you want to do reduced row echelon form on matrix A, correct? Hit equals, and it will do that. This is called a reduced row echelon form matrix. Let's write it down on our paper here and see what it means. First, let me get rid of this so I have room to write. Here's what it should look like. 1, 0, 4, 0, 1, -2. Close the matrix. So now we have this. You should write it down. What's it mean? Remember, these are coefficients. Would you agree, don't put this on your paper, but here's an x, here's a y, and there's an equal sign, correct? Here's an x, here's a y, and there's an equal, correct? What we're looking for is, if we get solutions, we're looking for a row of ones to go diagonally right here in our coefficient matrix portion of it, on the left side of this bar that we put. This says 1x equals 4, correct? That means 4 is the x value of this point right here. What does this say down here? That 1y equals how much? There is our solution to this system right here. 4, negative 2. It was weird to punch that in. It takes a little bit of practice, and once we get used to it, it's like, holy cow, we can do this without graphing. It's linear. This matrix tells us now that our system, which was this, has solutions at 4, 2. This 1 right here is in the x position. It's saying that x equals 4. This 1 right here is in the y position. It's saying that y equals negative 2. So let's classify it. Consistent or inconsistent? Consistent, because we got an answer. Dependent or independent? It's independent. Just takes a little bit of memorizing that independent means you got one answer. Let's do that again. Here's how I want to do it. We're going to do it a little different than what Mrs. Cola was doing. This is a linear system, right? Linear is the only thing we could use our graphing calculator matrix for, and we got to make sure it's all lined up. Like for elimination, x is on top of x's, y is on top of y's, equals on top of equals, and constants on top of constants. Let's write an augmented matrix to the right. Augmented matrix means what's our coefficients slash constant? Wouldn't it go 1, negative 2, negative 5, and there's that bar right there. You with me on that? For the top row. Bottom row would be 3, negative 1, 5. Are you all good with that? Okay? Now I want to notice something. You see, I have not cleared anything out of my calculator yet either. It's still sitting there waiting for me. Cool? Let's go and enter this into our matrix again. How do I do that? What do I need to hit? Second matrix is the main idea. And do we want to do math on it right now, or do we want to edit this puppy right now? We've got to edit it. Isn't it already set up for 2 by 3? Correct? So you just get down with your arrow and get your cursor to right here, right? And now you're going nuts by hitting these numbers. You go 1, enter. Then you're moving to the right, negative 2, enter, negative 5, enter. 3, enter. Negative 1, enter. 5, enter. You see how all entered all that stuff in. Then quit, right? Then quit. Cool? Are we okay? Now, I have quit. Matrix A is now what I want it to be. It is this matrix right here. Sorry. It is that matrix right there. What I could do, if I want to, isn't this programmed right here in my calculator to say, you would like to do reduced row echelon form on matrix A? I don't have to go through all that rigmarole again if I don't want to. I hit enter, and it will do it. That's the previous example that I wanted to. I just have to hit enter, and it will do that for me. It put my new matrix A, because we just edited it, right? Matrix A, it was programmed to do that. Now, write the reduced row echelon form matrix down for me. It's 1, 0, 3. If that 3 would show up. 0, 1, 4. Is everyone cool with where the matrix came from? All right. Now we got to analyze this. It's like, whoop-de-doo, what's that mean? What we're looking for is right here. We're looking for a row of ones, diagonal ones, if you will, on this side. Do we have that? What does this one represent? X or Y? It says that x equals 3. What does this one represent right here? That y equals 4. This, if we put the coefficients back in, says x, y equals number, x, y equals number. It says that x equals 3 and y equals 4 is what that says. That's our solution right there. So, consistent or inconsistent? Consistent. Since we got one answer, that is independent. Haha. And can you imagine if I gave you a sheet of like 30 systems to solve? It would take you 5 minutes with this, because you've got it all programmed in. All you got to do is go back and change those coefficients and then hit enter. Change those and hit enter. That's how great this will be. So let's do another one. Ooh, something's different. What's different? 3 variables. So this is a 3 by 4 matrix, correct? Let's do this. Let us make an augmented matrix to the right. Got to be in order. If the first one's x, y, z constant, all the rest of them better be x, y, z constant. So 5, 3, and etc. Make your nice, neat augmented matrix. Augmented matrix. And I can tell you that we could solve that system by elimination, but with there's 3 variables, you got to cancel out the z's first, then you got to use that to substitute back in to find a y, then you got to use it to substitute back in to find an x. It takes a long time of an ordered triple situation when you got 3 different variables. But with a matrix, it's super simple. So do we have this? And it's all closed up right here. Go back to second matrix. Now I want to give you some advice. I would advise not changing this matrix A. I'm going to keep that there for all my 2 by 3 matrices. Can we go down to matrix B and another one for 3 by 4 matrices instead? So I'm going to edit, hover over to edit, and what do you want it to be? It's set up as a 1 by 1 right now. What do we want this one to be? 3 by 4. Now, if you wanted to change matrix A, you could. It's whatever you're comfortable with, but you're going to have a bunch of 2 by 3s and a bunch of 3 by 4s. I like to have them both in my calculator. So then go back and type all those in. Go down. Oh, man. This computer. If you video people need help, you come on in and we will help you. You got to make sure you type them in and you hit enter after the last one also. Sometimes people don't hit enter when they're on their very last one and it doesn't get entered, so got to double check that you have it. Up to that point, students are usually great. They're like, I can do that. I can edit my matrix. What do you have to do next? Quit out of it. Okay? And now we can't even use the enter button again, because isn't it sitting there waiting for matrix A? So we got to go back to the whole new process because we're in matrix B. So I need to do second matrix, and I want to do math on one of these matrices. So let's go to math. Right? And then we need to do reduced row echelon form, that RREF, which is choice what? And if you go up, you could get to it faster than going down. So choosing option B. Reduced row echelon form, it's waiting for a matrix. Waiting for a matrix. Which one do we want to put in it? So we got to go to second matrix and hover over B right here with our cursor and hit enter. And it's sitting there waiting for me to do it. And boom, there it is. Write down that reduced row echelon form matrix. Please let me help you if you're lost in your calculator. Last one is where the bars go. Like, come on, dude. If you didn't get this, is this right? Did I get the right one? Yeah. If you didn't get this, that means you made a typo in the previous one. That's the hardest part about it. Did you type the numbers incorrect? Did you put a -5 when it was supposed to be a -5? So if you didn't get this, we'll fix it later. Just copy mine down. And let's see what this means. What's this mean? What's this guy? First of all, did we get a diagonal 1s right here? And everything else is 0s. So we'll get a solution. What's this mean? X equals 2, right? What's this one mean? Y equals -1. And this one means what? z equals 3, that's our ordered triple right here. It goes x, y, z. They're always in alphabetical order. This is an ordered triple. And you're like, when would you ever need to graph stuff with 3 things? Well, anything three-dimensional, like, oh, I don't know, all the video games that are out there. Like, how do you think they get those graphics? That's three-dimensional stuff. Graphing things three-dimensionally is way over your heads, but that's how they do it. 2, -1, 3. And once you get to Calc 3, you'll learn to graph stuff three-dimensionally if you ever take Calc 3, which I have and you haven't. Let's try again. Oh, sorry, classify it. Classify it. What is this? Consistent or inconsistent? Yep. And dependent or independent? Independent. Nice. Next. What kind of matrix will we have? 2 by 3 or 3 by 2, 3 by 4 or what? Give me a augmented matrix. Many people don't like to write that one down. They just want to try to type stuff into the calculator straight from this. I don't advise that. We make more typos. And if you make a typo, then the whole thing's wrong in the first place. I don't want an equal sign, Mr. P. Come on, pen. Then go edit your 2 by 3. Edit this guy. Down, down. 1. Enter. -1. Enter. 2. Enter. -2. Enter. 2. Enter. 5. The good thing about the 2 by 3s is you can see all the coefficients to double check to see if you typed it in right. When you get those 3 by 4s, you can't see them all the time. Goody? With that? What do we do next? We quit out of it. Wherever that is. And then, I'm not set up for this, right? So I got to go through the whole motion again. So let me give you a little advice while I'm thinking about it. If you were doing your homework, what I would do is I would do all the 2 by 3 matrices that I see first. Get them all done. And then I'd go back and do all the 3 by 4s. So I wouldn't have to keep going through this process over and over and over again. But that's up to you. It's also good to go through the process so you can remember how to do it over like a long weekend when you don't have school on a Monday or something. So it's up to you. But second, matrix, math, reduced row echelon form, which is choice B, and which it's cumulative sum, so I got to clear that out and start over. Wrong way, dude. What happened? Where's B? Oh. That would make more sense. Second matrix. Which one do we need? A or B? Ooh, write that down. Write that down. Write that down. 1, -1, 0, 0, 0, 1. Close it up. Ooh. Do we have a row of 1s going do we have diagonal 1s here? That means one solution is out. We have to look at this and see if this is infinite solutions or no solutions. And all you got to do is look right here. This is saying 0 equals 1 right there. That's what that's saying. 0 equals 1. Yes or no? Does 0 equal 1? No solutions. How come there's no solutions? What would that mean about these 2 lines right here? What would that mean? Parallel lines. No solutions. Parallel lines. Because there was not 1s diagonally, that means that there was either infinite solutions or no solutions to this system. How did I determine? I looked at these 2 particular numbers right here. This says 0 equals 1, which is not true. Consistent or inconsistent? It is also a 2 by 3. Let's punch that puppy in. Write ourselves a matrix here, augmented. then edit it up. I got mine edited. I'm quitting out of it. In this matrix A, matrix A, matrix A, matrix A. Am I set to run? Just hit equals again, and it'll give me the answer. Is this doing reduced row echelon form on matrix A? So all I got to do is hit equals, and boom, there it is again. There it is again. So I got a matrix of 1, 2, 6, 0, 0, 0. Correct? Do I have ones going diagonally here? Nope. I'm left with this. 0 equals 0. Yes, always use the bottom one. 0 equals 0. Yes or no? So, infinite solutions. Uh-oh. In the form. Uh-oh, uh-oh, uh-oh. In the form. Here's what this really says right here. That y equals y. Right there. Y equals y, 0 equals 0. Isn't that an infinite solution right there? Here's what this guy right here really says. Jot this down to the side of the matrix also. X plus 2y equals 6. Isn't that what that top one says? 1x plus 2y should equal 6. Isn't that top row right there? So remember, we've got to solve this for one of the variables. You can, if you want to. If you want to. Most people are comfortable solving for y. Which one's got a coefficient of 1? Doesn't x have a coefficient of 1? Can't you get what you have to do? So let me make this bigger so we can see what we're doing. Wouldn't we say that would imply that x would equal negative 2y plus 6? Isn't that really what x equals right there? So, our infinite solutions guy, we could do this. Y is y. And x is negative 2y plus 6. And that's like backwards from what we were doing before, because we always had an x right here, and we had what y equals right here. But don't we already have what x equals in this situation? So that needs to go in the x position, and this would just be a y. If you wanted to do it the other way, and you wanted to solve for y, you could get this answer. You could say, all right, well, 2y equals negative x plus 6, y equals negative 1/2 x plus 3. This ordered pair of x, comma, negative 1/2 x plus 3 is the same answer as that. Either one of those is acceptable. If you want to get y all by itself, then this goes in the spot of y. If you want to get x all by itself, then this goes in the spot of x. I kind of drew my arrow backwards. It's up to you. But I wanted to show you this way for when we get the 3 ordered pair situations, like, oh, this one right here. Let's make ourselves a matrix and get this puppy typed in. T. Close. Edit it up. We're editing matrix B. I forgot to quit out of it for those who are watching what I was doing. Got to quit out of it first, then go to math. working. Matrix B. Then write your augmented matrix down. Now we have to augment it. Write your reduced row echelon form matrix down. Yep. You made a typo then, is what happens if it does. Did the rest of you get? Okay. It happens to the best of us. We hit the wrong button and we typed the thing in wrong. For now, just copy mine down. Okay. That's something you really got to watch. If you don't type it in right, then it's just a big waste of time, you know. So we're good with this? Do we get ones going diagonally? Yes or no? Nope. So we look here. Do we have infinite solutions or no solutions? Please put 0 equals 1, cross it out, and say no solutions. Parallel lines. Inconsistent. Next. That's why I write a matrix first. What's the next one look like? How many more of these do we have? 3. Is that 3 more? Okay, good. Okay, good. 2. Is this the same one? 2, 2, 12, 3, 1. We just did that one? Okay. Okay, good. 14. Good. Now, here's what I was looking for. Look at the first variables are in it. 3. An x, a y, and a z. That means you've got to have a 3 by 4 matrix for this. So let's do our first row right here. Wouldn't it be 3, negative 2, 1, bar 2? You with me on that? Because this has got 3 variables. You've got to have that set up. Next guy. How many x's do I have? So 0 goes into place of where x was because there are no x's right there. Y's don't we have 1, and z's we have 1, and constants we have 5. Do you see why there has to be a 0 in the x place? Now which variable's missing down in the bottom row? So we have a 1x, we have a 0y, and we have a 3z, and then an 8 for a constant. Correct? You got to watch those zeros in there. So second matrix, edit. Wrong one. Second matrix, edit. Choice B. Tree. Second quit. Enter. Did I type something in wrong again? Is this what you got? Where are we at? We're on problem 14, right? Made a typo if you got decimals. Everybody got ones going diagonally? So, are there solutions to this one? Ones diagonally, 2, 3, 2. Cool, and then we're good at classifying. Let's save time because we're running low on time. Next ones get messy. We good? Let's go to 15. It's also a 3 by 4, so I can edit it up. And I have waited as long as humanly possible to show you this next trick on a calculator. I've never wanted to show students how to do this, but it's time that you learn. You should get decimals in this particular one. Those are nice, neat decimals. Sometimes you'll get some real nasty decimals, too. We don't want decimals. We want fractions. Your calculator can change any decimal into a fraction just like that by hitting this. Math, enter, enter. If you hit the math button, then hit enter, and then hit enter, it will change that into fractions for you. Math, enter, enter. So let's rewrite that. I know you didn't know it because we didn't want to tell you. 1, 0, negative 1/5. And then you can scroll over a little bit with your right arrow to see what those other things are. You can, once you're in this, you can scroll over. But math, enter, enter shows you what's up with the fractions. It'll change any decimal into a fraction for you. Enter, enter. When you do any kind of work on your calculator and you divide it out and you get a nasty decimal, if you hit math, enter, enter, it'll change it to a fraction for you when you're all said and done. Did we get a diagonal 1 situation? Nope. No solutions or infinite solutions? We're looking here, right? Isn't that 0 equals 0? So that's infinite solutions. Now, you're a smart group. We'll say in the form. Now, check this out. Go away. Let me get this in a bigger screen. I want to show you the work, and then let's see if we can learn a shortcut. Infinite solutions is the z situation. Isn't z our third variable? So this last guy is z equals z. Okay? Now, don't write this next thing down. This says, what's this guy right here? Which one is this, x, y, or z? This says y minus. On that said y minus 3/5 z equals 16/5. Well, what we're going to do is we're going to solve this dude for. We're going to solve this dude for y and see what y equals. Correct? Sorry, I had a brain fart there. But I want to see what y equals. And what would you have to do to get y all by itself in this situation? So doesn't that just imply that you got to add this 3/5 z over to the other side? That y equals 3/5 z minus 16/5. Please write this blue one down right next to this. That y equals 3/5 z minus 16/5. Cool. Hang in there with me. But would you agree that this guy right here says x minus 1/5 z equals 8/5? And don't we have to add 1/5 z over for that to get x all by itself? So I can jump straight to this. X equals, it's the opposite of this dude, because doesn't it have to get added to the other side of the equal sign? 1/5 what? Z plus 8/5. And what's the point of what we're doing here? It's for that crazy answer. But you see how all of these, what we have equal, are somehow got a z on the right side? These are all in terms of z, correct? So in our infinite solutions in the form of, I need an x first. Do we know what x is in the form of z? It is 1/5 z plus 8/5. Comma. Do I know what a y value is in terms of z? It's 3/5 z minus 16/5. And of course we know what z is in terms of z. What is z? Z is z. In your college algebra crazy infinite solutions answer, you must have the same variable in all three positions, or all positions, however many positions there are. We can get them all equal to z because that's what this says right here, that z equals z. This says y minus 3/5 z equals negative 16/5, but we got to add it over, so it's like the opposite of that dude with a z next to it. And this one, we just added that 1/5 over and it became a positive 1/5 z. We're getting them all in terms of z, and what I want is you to put those three things next to your matrix, but you don't have to do the baby step first equation if you don't want to. If you do want to, put it. If you don't have to and realize all you're doing is adding it over, because you should have a bunch of ones and all that crazy situation in that guy. One more, I think, right? Watch out for your zeros. Watch out for your zeros. Then I'll show you another trick with your calculator once you get it edited in. So like get your matrix all typed in and edited, and I'll show you another trick. Sometimes we don't like to show all these tricks, but might as well. Once you get to learn to use this puppy, it can do a lot of cool stuff for you. I think. I'm not too familiar on how to do this, but I got my matrix entered, and I'm sitting here flashing, but this previous entry didn't say reduced row echelon form on matrix B. But if I hit second entry, it will say that. Hit second entry again, it'll go back up to 2 entries ago, right? Every time you hit second entry, it will take it up to like what that entry was. So I hit it once, it took it up to answer as a fraction. If I hit it twice, that's what my previous entry was right there. So I hit second entry twice. For those who didn't see that, I'll do it again. I'm sitting there flashing, doing nothing, right? If I hit second, an entry is down here right above your equal sign. If you hit second entry, it will, whoa, that took me up 3 times ago because that's the 3rd time I hit it, sorry. So I'm just going to keep on hitting second entry until I see it say reduced row echelon form on B, because that's what I want, correct? Now hit, boom, enter. Do I got decimals? Yes or no? How do I change them into fractions? Math, enter, enter. Boom. Nice, neat fractions. So you write your reduced row form matrix again. One solution, no solutions, or infinite solutions. Because we don't have ones going diagonal, we got to look at these two brothers, which is 0 equals 0, which is infinite solutions in the form of This guy right here, off to the right, the 0 equals 0 part, what does that say variable-wise? Z equals Z. The dude right above it, this will say y equals, don't we have to add this one z over to the other side? And that's the trickier part about it. People will realize you got to add this over, but they forget the z, right? It's not 1, it's 1z. You with me? There's a z there, z plus 3/4. Now get me the top equation. X equals 2 what? 2z plus 13 halves. Then your final answer goes x, y, z, all in terms of z. 2z plus 13 halves, z plus 3/4, and z. Awesome. If you don't have a graphing calculator. If you go to our class website where Chapter 3 is, and if you scroll down to this, here's the day 3, the lessons with matrices. You see this link that I have here for a website with a matrix solver on it. If you want to go to that, it will ask you the same thing through your computer. Like if you had a 2 by 3 matrix, you put in 2 by 3 and hit submit, and then it'll ask you to type that stuff in, and it will put it in reduced row echelon form for you. I want to explain that this is easy. Why did we show it to you on your calculator? Because you calculator on the ACT, and you can't use your computer. Cool. Linear equations that you could use that matrix. The stuff that you just took a homework quiz over, though, with the quadratics, intersecting an absolute value, you can't use matrices on those. It's got to be on that. So if you don't have a computer, or excuse me, you don't have a calculator, you can use your computer.